Jana, we have you all set for the final? Christian, how are you doing?
Good, how are you?
Good. Can you guys hear me okay, or do I need to run downstairs and get the headset?
I can hear you.
Okay. Hi. Hi, Abby. How are you?
Good, how are you?
Good. I cannot believe that this semester is to the point where this is our last class. It's like, in the middle of class, when, those 3 hours class seem to go on forever and ever, but like, big picture, did this semester just fly by, or is it me?
Oh, I'm pretty quick. I was surprised.
Yeah. Do you guys feel like you learned anything this semester in math?
Yes.
All right. All right. Well, I figured my goal for the day is to just review. And I think we mentioned last class when I made the final, I was able to, in Blackboard, open up all 4 tests. And so I picked a spattering of questions from them, changed the numbers so that they're not identical, but they're pretty gosh darn close. And so I thought that if it's all right with you folks today to review, we might just go through those 4 back tests and do them together as a group. Does that sound like a plan?
Works for me.
All right. Well, now I have no idea what time it is. I was downstairs and the time on our cable box said it was later than my computer says. My phone's in agreement with my computer, and my watch is several minutes different from both of them. What time do you guys have?
I have 5:57.
Okay, that's what my computer says, so that's what we'll go by. So we'll wait a couple minutes to get started. But let's see, Abby, your last name is McCarthy, right?
Yes.
You here. Egypt, we've got you here. Gianna, we've got you here. And Christian, we've got you here. Hopefully we'll have a few more people come. So, are all of your other classes winding down? Do you have just exams the rest of this week, or are there classes that are still meeting besides exams?
No, I have just exams and 2 papers due.
Ooh. Which would you rather do, a paper or an exam?
Probably an exam because I know the answers in front of me.
When I was getting my master's degree, way back in the day, I had to get my master's degree in order to keep my teaching certification. We used to be able to get permanent certification by getting a master's in teaching in a public school district. And I got it. It took me the full 5 years because I was teaching full-time at a high school at the time. And in those 5 years, I moved twice, got married, and had my first 2 children. And so when I was finishing for my master's degree, I was meeting with my graduate advisor. I had decided that I wanted to get my master's in math and not in education courses because I enjoyed my math courses ever so much more than my education courses. And so before my last semester, I met with him and he said, okay, in order to get your master's, you have 3 choices. You can write a thesis, you can do a theorem proof, or you can take a comprehensive exam made up of questions from some of the different courses that you took. And I so wanted to do the theorem proof And he looked at me and he told me, I'm going to decide for you. You're taking the comprehensive final, because at that point in time, I was like 6 months pregnant and he had a baby at home and he knew it. And he said, because that comprehensive final is going to end. As opposed to a thesis or an exam proof that could go on for years, where you are in your life. You know, it was a much more finite thing. So, yeah. Okay. All right. Let's see. Is Mackenzie here yet? No. Okay, Samantha, I have you. Naomi, I have you. Abby, I have you. Christian, Courtney, Gianna, Egypt, Katie. Is there anybody that I'm missing? Yes, somebody just came in. Stephanie, I'm sorry. I was looking at your bun in your eyes, and I have to apologize. I wasn't, without seeing the rest of your face, I wasn't being very good at putting a name with it. I'm sorry. So, but it's, you know, what's nice, I'm seeing more faces than normal. You know, it's, I think with this semester being blended, what I miss most is the more interaction with people in the classroom, that I can look up and look at your faces and see whether things are going okay or not. And usually in a classroom, people are more likely to do a little bit of that give and take participation wise. I think that's what I've missed most this semester. And while I feel I've gotten to know you folks a little bit, I feel like by not, you know, physically being with you, I'm not, I don't know you as well as I would have in a more traditional classroom setting, and that's sad. But we're almost there. Final exam. Everybody knows the final exam is tomorrow. It must be taken tomorrow, sometime between the hours of 8 a.m. and 8 p.m. Bare minimum, I would suggest you set aside 2 hours for yourself to take the exam. It's timed. It's set for 2 hours, but like the other tests, when the clock runs out, it's not necessarily going to kick you out. It's just going to tell me that you were late, that you took more than the allotted amount of time. But please make sure you set aside that time. I know that one of you have contacted me about outside commitments, that time frame won't work. If anybody else has outside commitments and that time frame won't work, I need to hear from you right after class today. Because with the final, I'm not bending. I'm not, I was surprised with the last test. Not just in this class, but in all 6 of the classes that I teach over the weekend, students were taking their exam for, and I was surprised at the number of people who said, I didn't know it was due then. When I think I've been saying every day for a while, you know, the litany of due dates, but that's water under the over the bridge, under the bridge. What is it? Water under the bridge. How's that saying go? Help me out here, folks. You know, you need to have it completed by 8 p.m. tomorrow, unless you have already made other arrangements with me, or make other arrangements before the end of the day today. I'm just looking, and I apologize, I'm opening up my other computer. In terms of the test, what I didn't write down that I should have is the exam is made up of 28 questions. They are each worth a little bit under 4 points. They're weighted equally. They're questions from the back tests.
Rachel says that when she clicks the link, it's saying that it's invalid and giving her a blank screen.
Tell her to type the address in. Don't just click on the link, but type the address in. because I know that when I copied and pasted it, and I have to apologize, I don't know how well this class is going to record. Yesterday, there was no internet in the Trella household, or it was very intermittent, and I just had a little bit of internet last night in terms of trying to send out Zoom links, and so I didn't want to try to open Zoom and create a link and email it for fear that it would overtax my machines. And so I just use my office hour link. And so that's why it's not a regular link for my daytime classes, because I wasn't sure about the status of our internet. I actually taught them from my office on campus today, but right now it looks like the internet's going to be okay, at least for tonight. So again, the folks that were here a little bit earlier, I was telling them that in my mind the best way to prepare for this test is to go over those past exams, because the test is made up of questions from the past exams. I think if you've taken the test, you should be able to access them through the Blackboard grade book. But what I did was I set them up so that I could reopen them to go through them today, because my goal today again is to ask you folks to help me do each of the prior exams. So I guess I'm going to ask, do you want to start with test 1 and work back to test 4? Or do you want to start with test 4 and work up to test 1? What order did you folks want to do these? Should we start with
Test 1.
the test 1? I was just going to say, should we start with the older content? So, whoops. All right. The octopus and penguin show has 15 animals in it. Only octopuses. Is it octopuses or octopi? How do you say that word in plural? And penguins. The animals have a total of 90 legs. How many of each animal are there in the show? Explain your strategy. So we looked at a whole bunch of different ways of doing this. What strategy would you folks use? How would you approach this? Would you draw a picture? Would you write an equation? Would you use trial and error? Would you make a table?
I'm sorry to interrupt you, but she tried it, what you told me to say, and it's still not working for her.
Oh dear. But it worked for you guys, right?
When it used the email link that you sent me, it didn't work, but I did mine through Blackboard, and I told her to do the same thing, and it still isn't working for her.
Okay.
I copied and pasted the link.
Uh-huh.
Should probably have her do that. That's how I got in.
Should I try to just email this to her again?
I just texted her and told her to copy and paste the link and see if that works for her.
Okay. Let's see. You know what? Should I send it to everybody in case other people are having a problem?
I found something that she could probably use.
Okay, so let's send it to everybody. And we'll call it Zoom.
She has tried to copy and paste the link too, and it's not working either.
Stephanie, I have a thing I think you can try.
Okay.
You see where that green check mark in the corner is, where that shield is?
Yeah.
And then click over to where the circle is with the, I think, an I, and it should say the meeting ID and the passcode.
I just sent an email out again, so maybe that'll work for her.
Let me see. Where is it again?
The top left corner near the
I
shield.
have the check mark, but I don't know, like it. What setting is it under?
Meeting information.
Um, hmm. It's not working for me either. Whoops.
Let me stop sharing for a minute. Is there something in here that allows us to invite somebody? Actions. You were looking at this check mark up here, Naomi?
Yes. And then it's the one over to the left of it.
I can't find it. That is so weird.
I'm not seeing anything.
Like when I click on the check mark, it has like a bunch of options like general, video, audio, share screen.
Okay, next to the check mark, do you have a little eye?
Yes.
Okay, so in that little
Oh.
eye, the meeting ID is 560-064-1776.
Here, let me see. Okay. Let me set
So
it.
tell her to just go into Zoom and use that as a meeting ID.
Oh, I'm in.
Naomi, you're great.
Oh,
We're trying to get you in. Did the link in the
Hello.
second email work, Rachel?
Sorry.
No worries, I'm sorry. I have to apologize. When I sent that last night, I barely had internet in the house, which is why I didn't send a regular Zoom invitation. And so I was surprised because in all of my day classes, there were one or two people who sent me emails that the link didn't work, but then there were several people who came. So Rachel, what we're doing is we're going over the back exams because the test is, the final tomorrow is made up of questions off of the back exams. And we're looking at the octopus and penguin question. And I'm begging people to tell me what they think they ought to do with this, because we had several ways of solving this. We made a table, we drew a picture, we wrote equations, we could do it with algebra. Any preference? The little kid in me wants to draw a picture. Are you guys all right if I draw a picture to solve this? 15 bodies. Penguins have 2 legs, so let's start by giving them all 2 legs. And if I give them all 2 legs, altogether I have, counting, 30 legs. And so if it's 15 penguins, it would be 30 legs. So far, is that enough legs?
I don't know if it's just me or anyone else, but you sounding kind of like glitchy to me.
Okay, let me go get the headset. I'll be back. Does this sound any better?
Yes.
Okay.
Yes.
I'm sorry, it was downstairs because it was in my briefcase from going into the office today. So 15 penguins is 30 legs, and that's not enough. So we have to start adding, because we have to turn them into octopuses, which have 8 legs. So that's 6 more, so that's 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 7, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 2, 4, 6, 8, 72, 4, 6, 8, 82, 4, 6, 8, 90. Now we have 98 legs. So we added legs to turn the penguins into octopuses until we had 90 legs, which left it. So add legs to make octopuses. So to get 90, there are, what are there? 5 penguins and 10 octopuses. How does that approach work? Would any of you have done this one a different way? Is this one all right?
Yes.
Okay, then I'm going to clear it and go on to the next question. Help! What are the 4 steps of Polya's problem solving, and do a little bit of explanation for them. Can anybody remember what the first step was?
Understand the problem.
I like it. And what does it mean to understand the problem?
By knowing what to look for.
Know what you're looking for. Maybe read carefully.
Know the vocabulary.
Mhm. Okay, great. Can anybody remember what the second step was?
Devise a plan.
Beautiful. We have different methods of problem solving. And what do we do?
Carry out a plan.
So we're going to carry out the plan. Work carefully. You willing to work stuff over if it doesn't work?
Look back
And what's that all about?
about what you learned and if there was, you could use another strategy.
What did you learn? Is there a better strategy? Good. Okay, with Polya's problem solving principles. Can I clear them? Okay, we got this pattern. 0, 1, 1, 2, 3, 5, 8, 13. Where the heck are those numbers coming from? Can anybody see a pattern there?
Don't you add the number behind? So like 1 and 1 is 2, and then 3 plus 2 is 5. So 5 plus 3 is 8.
Mm-hmm. So 8 plus 13 would be
21.
and then 13 plus 21 would be
34.
And then 21 plus 34 would be? Anybody? 55? Does anybody remember the name of this one? This is a famous sequence. It's called the Fibonacci sequence. It shows up a lot in nature. It shows up a lot in art. It's very interesting. So, okay, then next, garden is a square. We've got this square garden. It's 12 feet on each side. There's a walkway around it. And the walkway is 4 feet wide. How can we find the area of just the walkway? And remember, a lot of people on this test struggled with this one. There were some people who tried to take the walkway and divide it into smaller pieces. My suggestion is to take the area of the big square, the area of the outer square. Well, how long would this side be? If this side is 12, wouldn't I be adding 4 up and 4 down? So wouldn't this side be 12 plus 8 or 20? And wouldn't this side also be 20? So the area of the outer square would be 20 times 20 or 400. And then wouldn't we want the area of the inner square, which is 12 by 12 or 144. And if I just wanted the walkway, you know, this almost makes me think of looking at a picture frame and looking at the mat on a picture frame. And so can we picture having the big piece and then we're cutting out the middle? And if we're cutting out the middle, wouldn't we be subtracting or taking the difference? And so if I take that 400 minus that 144, let's see, oh, I should have written it better. 400 minus 144, let's see, 10 minus 4 is 6. 9 minus 4 is 5. 3 minus 1 is 2. So would it be 256 square feet? Does that work for you folks? Any questions?
No.
Then the next one, I was surprised that some folks kind of struggled with this next one on the test. It refers to Pascal's triangle. So Pascal's triangle, no, it's not going to pop. Let's see. It's going to let me make it a little bit bigger. Pascal's triangle. You guys remember, each number is, each row starts and ends with a 1. And then the other numbers are the sum of the two above it. So 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And then the next row would be 1, then 7, up, I'm going to write it down below. 1, 7, 6, and 5 is 21. 15 and 20 is 35. 20 and 15 is 35. 15 and 6 is 21. 6 and 1 is 7. And then I have a 1. Are you folks comfortable filling in the rows of Pascal's triangle? That part all right? If so, I'm going to erase those rows and shrink this back down to size a little bit. And so now what we're doing is we're looking for the sum of the rows. So this is considered row 0 and it adds to 1. This is considered row 1, and when I add 1 plus 1 is 2. So if I add the next row, row 2, 1 plus 2 plus 1, wouldn't that add up to 4? What happens when I add the next row? 1 plus 3 plus 3 plus 1 would give me 8. The next row is 1 plus 4 plus 6 plus 4 plus 1. See, what does that add up to? 5 and 6 is 11, and 4 is 15, and 1 is 16. What's the next row? 1 plus 5 plus 10 plus 10 plus 5 plus 1. What does that add to? 32. And now as I look at the sums of those rows, do you notice anything?
They're doubled.
They're double. 1 times 2 times 2 times 2 times 2. So that next one would be 64. And since they're just doubled, couldn't I think of this as 2 to the first, 2 to the second? Wouldn't this one be 2 to the third? Wouldn't this one be 2 to the fourth? Wouldn't this one be 2 to the fifth? Wouldn't this one be 2 to the sixth? So that the sums of the rows are my powers of 2. Does that make sense? I'm not hearing anything. Does that make sense, folks?
Yes.
Yes.
Okay, so then next part of the question asks, what would the sum of the 12th row be? Well, by what we just did, would that be 2 to the 12th? And so 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's start doubling. 2, 4, 8, 16, 32 times 2 is 64, times 2 is 128, times 2 is 250. Let's see, 128 times 2 is 256. 16, 32, 62, 4, 8, 16, 32, 64, 128. This is 256 times 2 would give me 512. Times 2 would give me 1024. Times 2 would give me 2048. Times 2 would give me 4096. And I think that's where we're ending up. Does that make sense?
Yes, but you were broken up very bad.
I'm sorry. And I don't have an answer for that because I'm in my house right next to the modem router thing. I'll try to talk more slowly. Is this any better?
Yes.
Yes.
for now.
Okay. So what's the sum of the nth row? Wouldn't it be 2 to the n? That one all right?
Yes. But you skipped number 5. Did you mean to do that?
Did I skip a question?
Yeah.
What question did I skip? Oh, the pigeonhole principle. Thank you. 10 black socks, 8 blue socks, 4 brown socks. How many must I take out of the drawer to have 2 of the same color? How many colors are there? How many different colors do we have?
3.
3. So if there's 3 different colors, if I out 3 plus 1 or 4 socks, wouldn't 2 of them have to be the same? Make sense? That was that pigeonhole principle, and I apologize. I just missed it. So should we go on to number 7? Should we just do every other one in the backtrack? Okay, number 7. What's the rule? Let's see, 8 goes to 24, 11 goes to 31, 10 goes to 28, 6 goes to 16, 13 goes to 37. Anybody see a pattern here? Any ideas?
Is it multiply by 3, then subtract 2?
It's 3 times the number minus 2. Trial and error. But somebody have a happy way coming up with that one. Are we all right with that one? Question number 8. How many different ways can you make change for 50 cents using only nickels and dimes? I think for this one, I don't know about you folks, but I would probably make a list. I could have 5 dimes, that would be 50 cents. If I have 4 dimes, that would be 40 cents. Then I'd need 2 nickels. If I have 3 dimes, that would be 30 cents, and I'd need 4 nickels. Well, we have 2 dimes, that's 20 cents, so we need 30 cents more, which would be 6 nickels. I could have 1 dime, which is 10 cents, and then I need 40 cents more, which would be 8 nickels. Or if I don't have any dimes, then I need 10 nickels. And does the orderly list work? Okay with this one? See, I'm thinking a number. If you multiply it by 9, subtract 51, and divide by 3, the result is 13. What's my number? Any ideas? You guys are really quiet. Can you hear me? Can you guys hear?
Yeah.
Could we work backwards? Let's start with 13. The opposite of dividing by 3 would be multiplying by 3. Then the opposite of subtracting 51 would be adding 51. Then the opposite of multiplying by 9 would be dividing by 9. Okay, where did it go wrong? Oh no, this is 39, not 69. How come you guys can do that? And so then this would add to 90. And so then the opposite of multiplying by 9 would be dividing by 9 is 110. Do you guys remember working backwards for these ones? Can I erase it? Anna, Bill, Chris, and Doris ran for president of their class. Bill received 50 less than Anna and 40 more than Chris. Doris received 80 votes more than Bill, who won the election. I think with these, we tried to put them on the number. And so this will be positive and this will be negative. So let's start with Bill, and he's 70 less than Anna. So I guess I'll have each case be 10, 20, 30, 40, 50, 60, 70. So Anna is ahead of him by 70. Bill has 40 more than Chris. 10, 20, 30, 40. So this is back there. Doris received 80 more than Bill. 10, 20, 30, 40, 50, 60, 70, 80. And so Doris won. You guys remember drawing a number line for those types of problems? Can we clear this one? Now, the next one I remember was a little bit of a stretch for folks on this test. Maria earns $50 an hour. Carl earns $40 an hour. They each earn the same amount of money each week, but Carl works 2 hours more than Maria. How many hours a week does Carl work? What approach would you folks take for this? Would any of you use a variable for this one? I'm thinking if we let X equal Carl's hours. Oh, I take that back. Carl works more than Maria. So let's instead let X equal Maria's hours. And so wouldn't X plus 2 equal Carl's? And wouldn't Maria make $50 times X hours? And wouldn't Carl make $40 times X plus 2 hours? And we know those are equal. Does that equation make sense to everybody? What would you do to solve it?
Would you distribute first?
Beautiful, I like it. So that gives me 50x equals 40x plus 80. Then what would you do?
Subtract the 40x.
Beautiful. So the 40x from both sides, because we want to keep our equation balanced. Gives me 10x equals 80. And then what would you do?
Divide by 10.
I like it. And so we get x equals 8 hours, which is Maria's time. So x plus 2 would be 8 plus 2, or 10 hours, which would be Carl's time. Now let's see, if I take 50 times 8, I get 400. And if I take 40 times 10 for Carl, I get 400. And so they're equal, and it checks. This one all right. Are you guys okay if I erase this, or am I erasing too fast? Next, Mary, Liz, and Martha are sisters with different jobs. One's a teacher, one's a doctor, one's an engineer. Mary's doctor is her sister. Liz taught her sister in school. Martha's match the sisters with their jobs. Explain how you got your answer.
Wouldn't this be the chart thing?
So we have a teacher, a doctor, and an engineer. And we have Mary, Martha, and Liz. So let's see. Mary's doctor is her sister, so we know Mary's not the doctor. Liz taught her sister in school. Oh, so Liz must be the teacher, right? So that means she's not the doctor or the engineer. So, oh my gosh, what can we say? Does it Martha have to be the doctor, which means she's not the teacher or the engineer? And so, well, if Liz is the teacher, Mary isn't, and she must be the engineer. Ellie? Can I clear it? Then we got this sequence 6, 10, 14, 18, 22. Which term would be the number 82? I think there are a couple of ways we could do this. Is there anybody who would just start listing all the numbers in the pattern until they got to 82? Otherwise, I think we said that the first number is 6. And the difference between numbers is 4. And we said that any number, the nth number, is a plus d times n minus 1. And so 82 would be 6 plus 4 times n minus 1. And once we have the equation written, can you folks solve it? Please do. Tell me what you get. I'll wait. Let me know when you have the answer. Did Anna join class? Anna, are you here? Rachel, how did you get in? Rachel? I got an email from Anna saying she can't get in class. And so Rachel, what worked for you so I can send it to her?
I ended up just clicking on the link and I just kept clicking on the link and eventually it opened.
Okay. Thank you. I usually don't check emails in the middle of class, but I have to slow down so that you guys can do this. Did anybody solve this and get a number for n? Did anybody else get an n is 20? Is that all right or no? And then the second part of the question, Gauss is strict, but that's equal to sum. That's 6 plus 10 plus 14 plus dot, 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 plus 78 plus 82. And remember, the district was line backwards. That's 82 plus 78 plus dot, 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 plus 10 plus 6. So then we get it down. We got to get twice the sum. Oh my heavens, each of these adds up to 88. And so there's 20 of them, just found that. So twice the sum is equal to 20 times 88. And so when I divide by 2, the sum is equal to 10 times 88, which would be 808. You guys remember the Gauss's trick where we lined it up backwards and noticed that they all added up to the same thing?
So I'm really sorry, but I can't understand you at all.
Oh no.
Like when you were talking through that whole thing, I got like bits and pieces and it was like really nothing.
Okay, is this better or worse?
That's better.
Okay, then I won't use the headset. And if it happens again, stop me immediately. Don't let me carry on if you can't hear. Do you remember Gauss's trick where we said the sum was equal to adding up all the numbers? And then we said it would equal to adding up all the numbers even if we put them in the opposite order. And so when we add it down, sum plus sum is 2 times the sum. And each of these columns would add to 88. With me so far.
Yes.
So there's 20 of them, which means that that would add up to 20 times 88. So if 2 times the sum is equal to 20 times 88, I'm going to divide both sides by 2, which gives me that the sum is equal to 10 times 88, which would be 880. Any better?
Yes, thank you.
Okay, and thank you for telling me I had to repeat it. I was getting worried. You guys were so quiet, I didn't know what was going on. Can I clear it, or do you want me to wait a minute? Does everybody who needs it written down have it written down? Okay, I'm going to clear it. Oh, and that was the end of that test. Do you guys remember all of that stuff?
Yes.
Okay, great. Then should we go on and look at test 2? Moo.
Quick question.
Sure.
When you get to like the Venn diagram test stuff for part 2, can you go over a little bit more?
Sure. Yeah, can I put a little bit of the responsibility on you? And when which is I think what is in test 2, the Venn diagram stuff, can you tell me where you have questions and stop me? Sound like a plan?
Mm-hmm.
Great. So test 2 was the one with the Venn diagrams and the sets. And what else was in test 2? Was it the different number systems? Ah! I went through and changed the settings on this one so that I could reopen it. And it's not letting me. Because right now I'm not in it. Let me back out. And we'll go look at it through this view. So first question asks me to take the base 5 number, 432, and write it in base 10. Working with these different bases, it's been a while, but in these different bases, do you remember the first column would always be the ones column? And if I'm in base 5, this next column would be the 5s column. And this next column would be 5 to the second, which would be 25s. And so I have 4, 3, 2. And so to change it into base 10, do you remember I'm going to take 4 times the column value, 25, plus 3 times the place value, 5, plus 2 times the place value, 1. So that gives me 100 plus 15 plus 2. So that's the base 10 number, 117. Remember, the place values were the powers of our base. And so this next one, we're starting with the regular number 21, and we want to express it in base 2. Well, in base 2, this would be my 1s, this would be my 2s, then 2 to the second, this would be my 4s column, 2 to the third, this would be my 8s column, 2 to the fourth, this would be my 16ths. The next one, 2 to the fifth, well, 16 times 2 is 32, and that's too big. Remember, if I'm in base 2, I only have 2 digits, 1s and 0s. And so if I were to think of taking 21 and dividing it by 16, it would go once, which gives me a remainder of 5. For that remainder of 5, I have no 8s, but I'd have 1 4 with a remainder of 1, and I'd have no 2s. So 21 would be the number 10101 base 2. Is that one all right? Questions on either of those different base numbers? Can we move ahead, or do you want me to go over them some more? Is it okay if I erase them? Yes or no?
Yes.
Okay, thank you. So then this one, I was surprised. We've got 324, and so that would be 300s, 2 10s, and 4 1s. But let's see, I've got to take away 100, 6 10s, and 7 1s. There aren't enough. So do you remember we exchanged 1 10 for 10 1s? So we'd have 1, 2, 3, 4, and then 10 more. And then we also had to exchange 100 for 10 tens. So we had one, and then we'll have 10 more. 1, 2, 3, 4, 5, 6, 7, whoops, 8, 9, 10. I don't have enough space. And then we'd have the 200s. And now we want to take away 7 ones. We want to take away 6 tens. 1, 2, 3, 4, 5, 6. And we want to take away 100. And so we're left with 100, 1, 2, 3, 4, 5, 50, 1, 2, 3, 4, 5, 6, 7. And so my answer would be 157. Do you guys remember doing the exchanges? And please notice, I need to have drawings that show me the exchanges, but looking at that mess I just made, I'm not going to take off for artistic merit, okay? Is everybody all right with that one? Can I go on to the next?
Yes.
Okay. Next one, I asked you to do this division using the scaffolding method. So for the scaffolding method, I need to work up and down. So I'm going to work over here in the margins. Scaffolding method, we've got 3,377, and I want to divide it by 16. Well, I think if I take 200 times 16, that gives me 3,200. And so that leaves me with 177. Well, if I look at 16 into 177, I think 10 times would give me 160, which leaves me with 17. And so I think if I have one more 16, I'll have a remainder of 1. And so my solution is 211, remainder 1. And so we'll say that 3,377 is equal to 16 times 211 plus my remainder of 1. Do you guys remember that scaffolding method where I stacked my divisors up top? That one all right.
Yes.
Okay, so I'm going to clear that. Next one's a fun one. We want to write 21,425 in Egyptian. And so 10,000 is the pointing finger, so I need 2 of those. 1,000 is the flower. I need 1 flower. 400, that's 100 is a scroll, so I need 4 of those. 20 would be 2 tens or 2 yolks. And then 5 would be 5 staffs. How fun is that? Do you guys wish we still wrote numbers like that? I think computation might get a little cumbersome, yeah? That one all right. to write 234 in Roman numerals. 100 in Roman numerals is a C. 10 in Roman numerals is an X, so 30 would be 3 X's. And 4, do you remember? For 4, instead of doing 4 ones, we said instead that it was 1 less than 5, so 4 would be IV. Roman numerals, all right.
Yes.
Now, this on a number line, on the last test, I was a little concerned. Most people nailed the number line, but there were 1 or 2 that had a couple of errors that gave me cause for concern. When we look at a number line, you have to remember that the positive numbers always go to the right. My first number is always going to start at 0, and I'm going to have an arrow to the right, so that's 3. And when I add, I draw them head to tail. So starting from this point, I'm going to have an arrow of length 4. 1, 2, 3, 4. And that takes me to 7. And so this arrow is 3, and this arrow is 4, and they add to 7. Because when I add, I draw them head to tail. Next one, again, remember on a number line, they always increase as you go to the right. A couple of people were doing their number lines backwards. We're going to start at 0 and have an arrow of length 6. Do you remember when we subtracted, we drew them head to head? So I want an arrow of length 2 that ends at the same place, so that I should be able to clearly see both arrowheads are there, and that difference is 4. So when I add, I draw them head to tail. When I subtract, I draw them head to head. On that last test, there were a couple of fraction number lines, and a couple of folks didn't put their numbers in the right order on the number line, and a couple of folks forgot that when you subtract, you draw them head to head. Is that one all right? And there should be clearly defined arrows on that number line if you want full credit. Can I clear this one? Now, Naomi, I think this is what you were looking at. We've got a universal set. Math is fun. A is the set AIU. B is the set MATH. C is the set FUN. So the first thing that we want, do you remember when I put the hat on A, that means A complement, and which means everything that's outside A. And so if my universal set is MATHISFUN, and I take out the elements of A, well, A contains the A, the I, and the U. When I take those out, what's left? I think I've got M, T, H, S, F, N. And so when I take the complement of a set, I'm taking my universal set, and I'm just taking out everything that was in the set that I'm taking the complement of. That one better.
Yes.
Next one is the intersection, A intersect C. And when I look at the intersection, I think of where two roads cross. And the intersection is what they have in common. So if A is AIU and C is FUN, what's common to both of them? What's inside both of them?
U.
U. Beautiful. And then this C is in between the C and the B, that stands for the union. And when I take the union, all I'm doing is I'm combining the two sets. And so I want everything that's in C, which is F, U, N, and I want to add to it everything that's in B, which is M, A, T, and H. And when I take the union, I'm combining them. That one better.
Yes.
Great. Can I clear it, or do you want me to wait a minute?
1 sec.
Okay.
I'm good.
Next one, we've got these sets listed, and I want to list them in a different form. So over here, I've got set builder notation, the set of all x, such that x is in the universal set. So I'm only looking at the numbers from 1 to 25, and x is equal to 4 times a natural number. Let's see, numbers that are 4 times another number, those are my multiples of 4. So wouldn't that be 4, 8, 12, 16, 20, 24? And if I get any larger than that, I'm outside of my universe. The next one, I've got the set listed by roster, 1, 4, 9, 16, 25. And I want to describe those. Well, aren't those numbers my perfect squares? So they're the numbers that are perfect squares in the universe. And now this last one, I want to write in set builder notation. So it's going to be the set of all x in the universe such that, now I have to describe x. There's a couple of different ways I can do it. I've got the numbers from 6 through 10 inclusive. So couldn't I say that 6 is less than or equal to x is less than or equal to 10? Or could I get fancy and say that 5 is less than x is less than 11? If I wanted to use strictly less than. And I guess if you got really fancy, one side could be strictly less than and the other side could be less than or equal to. But with something like that, when we're taking all of the numbers in between, does writing it with an inequality work?
Yes.
Okay. So now let me clear that. And now let's draw 3-loop Venn diagram with the loops clearly labeled A, B, C. This first one, I want A union B. Do you remember when we take the union, we're taking everything from both of them. And so for A union B, I want everything in A combined with everything in B. And so wouldn't it be that mess? Union is all of the elements of both. B, I'm going to have my Venn diagram again. A, B, C. And we said the intersection was the overlap. So this time I want to know, where does A, B, and C overlap? What's common to all three of them? And wouldn't that intersection be that little piece in the middle? And now the third one is probably the most involved, because for the third one, I'm going to take A, B, and C, and inside the parentheses, I'm looking at the intersection of A and B. The overlap of A and B is here. But if I look carefully, I don't just want that intersection, I want the complement. And so if the intersection is inside that red shape, wouldn't the complement of it be everything outside that red shape? I'm sorry, I failed coloring. But does that give you a better idea? Are those any clearer now?
Yes.
Can I erase them, or do you want me to leave them for a minute?
You can delete them.
I can delete them?
Mm-hmm.
Okay, thank you. Next one, we want two sets that are equivalent but not equal, and we want to use them to explain the difference. Well, my favorite examples are things like cat, C-A-T, and dog, D-O-G. They have the same number of elements. To be equivalent, they need the same number of elements. But they're not equal because they have different elements. To be equal, they have to have exactly the same elements. So equivalent, the elements can match up. They have the same number of elements, but they aren't necessarily the same elements. In order to be equal, the elements have to be exactly the same. That one okay?
Yes.
Fact family, well, we can use the commutative property. If we've got 3 plus 6 equals 9, we know that 6 plus 3 equals 9. And then related to addition would be the subtraction facts, where I could say that 3 is equal to 9 minus 6, or 6 is equal to 9 minus 3. And so those would be the 4 members of that family. Multiplication family, 8 times 7 is 56. So 7 times 8 is 56. And so 56 divided by 7 would be 8. And 56 divided by 8 would be 7. The related facts. That one all right.
Yes.
Okay. Can I clear them?
Yes.
Thank you. Rules for exponents. Over here, 2 to the 8th times 5 to the 8th. Well, because they have the same exponent, can I think of that as 2 times 5 to the 8th or 10 to the 8th. Next one, I have 3 to the 2nd to the 4th. Remember, when we raise a power to a power, we multiply those exponents. So that would be 3 to the 8th. Next one, they have the same bases. When I have the same bases, to multiply, I add the exponents. So that would be 6 to the 7th. And the last one, I'm dividing. They have the same bases. When I divide, I subtract the exponents. So that would be 5 to the 3rd. I don't care what they equal. I want them as a single exponential expression. And so now they're all each a single expression with exponents. I think on this test, I remember some of you working way too hard for that question. It's just recognizing your exponent rules. Is that one all right?
Yes.
So everybody remember that test. Let's go back then and look and see if it lets me into exam 3. Because I really thought I put one more night's worth of time on these so that we could open them. Let's try just opening it and see what it does. Is it going to yell at me or let me in? Oh, this one let me in. I must just not have saved the settings on test 2. Okay, with this one, the test for divisibility. Very few of you actually explained your test for divisibility. I got a lot of answers, not divisible by 2 because I can't divide it. And that's not what we're looking for. We're looking for those tests of divisibility. Also, some people split that up into 2 separate numbers. That's a single number. So my number is 209,331. And to tell if it's divisible by 2, I look at the last digit. And so since the last digit is odd, it's not divisible by 2. For divisibility by 3, remember, for divisibility by 3, I added the digits. And so when I add those digits, and I guess I was concerned because a couple of people, when they added them, got the wrong sum. 2 plus 9 is 11, 12, 13, 14, 15, 16, 17, 18. The sum of the digits is 18. And since the sum is divisible by 3, the number is divisible by 3. There is no need to divide to tell. And then when I look at the number, we can say that it's not divisible by 6 because it must be divisible by both 2 and 3. So this is my divisibility by 2, by 3, by 6. For the divisibility by 5, that's not a 5 or a 0, so it's not divisible by 5. And I have to apologize. This is a logistical mess because I'm trying to fit it in here. I should have made more space on the page. for divisibility by 9, we already said that the sum of the digits is 18, which can be divided by 9. So the number is divisible by 9. Do you folks remember those tests for divisibility? Just ways of, and they help when we get into fractions, knowing whether we can divide by 3 without going and doing the long division out. Knowing whether we can divide by 9 without doing the division out helps us when it comes to things like reducing fractions, knowing whether we have that common factor or not. Do you folks remember those or no? This question okay? Can I clear it? Can you guys still hear me?
Yes.
Okay. Is this one better? Do you guys need more time with it or no?
No.
Then next question. On a number line, when we draw the number line, remember we had said that our numbers start at 0, to the left is positive, to the right, I'm sorry, I'm getting my directions mixed up. To the right is positive, to the left is negative. So I'm going to start with -3. Negative arrows go to the left. And now I want to add +4. Positive arrows go to the right. And when I add them, I draw them head to tail. And so my answer here would be 1. The next one, I'm starting with that arrow for +6. And then when I subtract, I draw them head to head. So I want from this, with the head of the arrow here, an arrow for -2, and those negative arrows go to the left. And so -6 minus -2 would take me to 8. Again, I need to see clearly the heads of the arrows. This is the arrow for +6, it moves right. This is the arrow for -2, it moves left. That one all right. Can I go on to the next one?
Yes.
Sieve of Aristophanes, I start by circling 2, and then I cross off every second number, because every second number would be divisible by 2. And are you guys all right if I don't write that sentence out? Then the next number that's not crossed out is 3. So I'm going to cross out every third. 1, 2, 3. 1, 2, 3. 1, 2, 3. And in doing so, I'm crossing out all of the multiples of 3. Next number that's not crossed out is 5. So I'll circle 5, and then I'll cross out all of my multiples of 5, because those numbers would not be prime. Next number is 7. I'll circle 7, and then I'll cross out all of the multiples of 7. Then I'll circle 11 and cross out the multiples of 11. And after that, everything that remains should be prime. Giving me my prime numbers. So we'll circle the first number, then cross out its multiples. Then we'll circle the next number that's not crossed out, and cross out its multiples until all we have left are the prime numbers. Is that all right? Do you folks remember your Civivirsophanes? Can I clear it? Does anybody need more time?
Yes.
Yes, I can clear it, or yes, you need more time.
Need more time.
Okay.
29 is not circled or crossed out.
That's because I don't have my glasses on. And so I did not see that it was not. I'm sorry. By the end of the day, after staring at computer screens all day, I can't focus with the glasses because my eyes are bad and they're bifocals. And at some point in time, I don't know which part of the glasses to look through anymore. So I take them off and I just didn't see it. Thank you very much for correcting me. Better?
Yes.
Let me know when you guys are done.
I'm done.
Okay. So I'm going to clear that. Whoops. Prime number its only factors are 1 and itself. Only 2 factors, 1 and itself. A composite number is a number that's not prime, has more than 2 factors. One is neither. It has only 1 factor. It's the basic unit. Everybody remember those definitions. Can I clear that one? Anybody need more time? To see if the number 301 is prime, what we have to do is we have to check if it's divisible by any prime less than its square root. And so if I take 301 and divide it by 2, it doesn't go evenly. If I take 301 and divide it by 3, that doesn't work. 301 divided by 5 doesn't work. 301, let's see, can we divide it by 7? 7 goes into 34 times 28. Yep, it's divisible by 7, so it's not prime. And to determine if it's prime or not, we would have to go back and look at all of those numbers that we circled in our SID that were less than 17.3 and see if they divide our number evenly. As soon as we find one that divides it evenly, it will not be prime. That one all right? Can I clear it? Euclidean algorithm for the greatest common divisor, we said we're going to take the bigger number and divide it by the smaller number. So that would go in twice. And I have a remainder. Then we're going to take that number I was dividing by and divide it by the remainder. And because the remainder goes in evenly, that's going to be my greatest common divisor. And then to use it to help us find the least common multiple, what we do is we take the two numbers and multiply them and then divide that by the common divisor. Now, if you're a glutton for punishment, you'll do this multiplication out and then divide that long division by 12. But can anybody look at this and realize that 12 goes into 120 10 times? And so this is going to give me 252 times 10, or 2,520 would be my lowest common multiple. Are those two all right? Can we move on, or do I need to wait a minute? Can you guys still hear me okay?
Yes.
Because if it doesn't work, I'm getting terrified because that means our internet is acting up again. So can I clear this one? Are we done with this one? These two, actually, I apologize.
Yeah.
Okay. Then 17-year locusts and 11-year locusts both emerged in 1980. When will these insects' descendants next emerge the same year? This is actually kind of like that homework question that dealt with the tricycle wheels. And the two wheels were different sizes, and we wanted to know when the same points would be on the ground again. And in order to do that, what we're looking for is the least common multiple of 17 and 11. And this time, because they're relatively prime, they have no common factors. The least common multiple will be 17 times 11, which would give me 187 years later. How's that one? I know a lot of people seem to be stumped by that one. When they come out again, we started listing all the multiples of 17. And all the multiples of 11. We could go ahead and keep on doing that until we got an overlap. But because those numbers are relatively prime, we can just take their product. That one all right?
I actually do have a question.
Yep, Kate.
Since it said like which year would they be together again, would we have to add that to 1980?
We probably should. I would have accepted if you just got to the point of knowing the 1980, 187 years. But if we wanted to know the exact year, we probably should add that in. And so that would be in the year 2167. And should I go off on a tangent? This question always makes me think of back when my youngest daughter was playing travel softball. And it was when the 17-year cicada bugs were out. And there were so many, it was almost like a locust. There were so many of those bugs that they'd have to stop the ball game to pick the bugs off of the little girls. Oh, it was nasty. So I digress. Is everybody all right with this question now? Can I clear it?
Yes.
Okay. Next one asked for two different dot pictures. So first we want -3. And for -3, we could just have 3 negatives. Or do you remember we could have something like 4 negatives and a positive, and those two would cancel each other out. In the same way for +4, I could just have 4 positives, or I could have 5 positives and 1 negative. Can I clear them? Question 10, a dot picture for -5 minus -3. Well, I could have, draw the dot picture over here, -5, 1, 2, 3, 4, 5, minus -3 means I'm taking away -3, and that would leave me with -2. For B, my mail time story, negative numbers are bills. So I get a bill for $45. Positive numbers are checks, and a check for $100. So bill is money I lose, check is money I take in. I have $55 left. And then C, with my number line, I'm going to start at 0. And then I want 4 arrows, each of -2. 1, 2, 3, 4. They're adding -2 to itself 4 times, gives me -8. Next one, if I look on my number line up above, the further to the left, the smaller the number, the further to the right, the bigger the number. So -2 is greater than -8. -5 would be smaller than +2. Those bars mean absolute value. The absolute value of 5 is equal to the absolute value of -5. And then 0 is to the right of -2, so 0 is bigger than -2. Those all right? If so, can I clear them?
Yes.
Then student said that 2 is less than or equal to 5 is wrong. And the student is right. Yes, is 2 is less than 5. But we can also say that 2 is less than or equal to 5 because this includes less than. It doesn't mean that they're equal. It means that it could possibly be equal. Doesn't mean they have to be equal. The next one, a lot of people added the numbers okay, came up with the right balance, but they never wrote it as a sum of integers. To write it as a sum of integers, we're starting with $129. We're adding 341, and then we're subtracting 13, subtracting 47, and subtracting 29. And then after we do that arithmetic, we'll get our total. We could also write that as 129 plus 341 plus -13 plus -47 plus -29. And then we'd have to say what it equals. Is everybody all right if I just set this one up and let you do the computation? Those two all right? Can I clear them? Next one was just doing the arithmetic. And again, you really should be doing this arithmetic without a calculator. If we're looking at multi-digit multiplication, I'd like to see your work. Over here, -9 times +5. Negative times positive is negative, and 9 times 5 is, oh, is this, oh, that's the last of the problems, okay. 9 times 5 is 45, so that one is negative 45. Negative 6 plus positive 10 would give me positive 4. The absolute value of negative 5 would be 5, plus the, I'm sorry, minus the absolute value of 4 would be 4, and so our final answer here is 1. 36 divided by 4 is 9. Negative divided by negative is positive. And then lastly, to subtract a negative, we add the opposite. And the signs are different, so we'll take the difference and use the sign of the greater absolute value. So that last answer is negative 9. In the triangle, I have to apologize. This was extra credit. Nobody lost points for this one. This was supposed to actually be like one of those ones in the book where you had to fill in the circles with numbers so that each number in the corner was the sum of the other two. And so if I look at 7 as being 3 plus 4, 1 as being 3 plus negative 2, and 4 plus negative 2 is 2. And so it would work. I couldn't figure out how to type that one into Blackboard correctly, and that's when that became extra credit, when I saw what it looked like when I typed it into Blackboard. How's this test? If it's all right, shall we look at the last test from this past week? The test on chapters 6 and 7. Let's see if this one lets me open it. And I have to apologize before I open it. In the words that come up here, it has a different time period for this test. I would like it to be 120 minutes. Again, though, if you go over time, it's not going to kick you out. It's just going to say that you ran over time, and it's going to let me know that it took you extra time. On this test, I think everybody got question 1 fine. Equivalent fractions, we're just going to multiply numerator and denominator by the same thing. So we could have 10 over 16. We could have 15 over 24. We could have 20 over 32. We could have 25 over 40. I mean, there's an infinite number of them. Next question, I was a little concerned because a lot of people gave me the answer. A lot of people looked at this and said, okay, all right, well, that's 4 over 15. But they didn't illustrate it using the rectangular region. To illustrate it, do you remember we said, okay, if I have this square, I'm going to say that each side has a length of 1. So one side I'll divide into thirds. And so this would be 2/3. The other side I'll divide into fifths. And so on this side, this would be 2/5. And so the area determined by those is 4 out of, well, if this is 1 and this is 1, altogether there are 15 blocks on the inside. And so that product would be 4 15ths. And very few of you drew me the picture. Is everybody all right with that picture? Can I erase it? Are we done with it or no? I'm going to clear it, okay? Next one, to order the fractions. Do you remember, in order to order them, we wanted to get a common denominator. And here I think the common denominator is 36. So 2/3 would be 24 over 36. 5/6, multiplying top and bottom by 6, will give me 30 over 36. I've got 29 over 36. 8 over 9, if I multiply by 4, would give me 32 over 36. And 3 over 4, if I multiply by 9, would give me 27 over 36. And so now let's see, I think the smallest is the 24 over 36, which is 2/3. Next smallest is the 27 over 36, or 3/4. Then the 29 over 36. Then the 30 over 36, which is my 5/6. And then the 32 over 36, which is my 8/9. The next one, we have a negative mixed number. And what we said with mixed numbers, you have to be real careful if they're negative, because it's the negative of the whole thing. So it's going to be the negative of, I'm going to take 3 times 7 plus 2 and put it over 7. So that's going to be negative 23 over 7. Can I clear those two, folks? Not hearing anything, I'm going to. Next one, a lot of people were fine doing the addition. A lot of people told me that that was 3/6 plus 1/6, which is 4/6. And then I accepted that, or if you reduced it to 2/3, that was gravy. But very few of you used shaded regions. For my shaded regions, I guess I'll use circles. So that's 1/2 plus, see, next circle I'd have to divide into 6 equal regions. So when I take 1/2 plus 1/6, well, if I try to put those together, I'd have the 1/2 and the 6, and so that would give me 4/6, which then if you want to, you could reduce to 2/3. For the number line, I'm going to take 1 and I'm going to divide it into 4ths. And then I'm also going to divide it into 8ths. And then I'm going to take 3/4. And then remember to subtract, we want to draw those two arrows head to head. This one has a length of 3/8, and my final answer would be 3/8. But again, in order to draw subtraction, we're drawing the two arrows head to head. With the fraction strips, I saw some rather creative artwork. First strip is 7/8. So I'm going to try to divide this into 8 equal regions. And I'm including 7 of them. 1, 2, 3, 4, 5, 6, 7. And then I'm going to take away 1/4. Those strips are all equaling 1, so they should all have the same length. And I'm going to divide that into 4 equal sections. And that 1/4, so it should visually be the same as 2/8. Now to show the difference, in class we always lined up another one from here, but honestly I was rather impressed with somebody in class who, in order to show the difference, lined up another one down below, and they said, okay, well, when I take away that 1/4, do you see how when I take away that 1/4, this is what's left, which would be 5/8. But those strips, they're all length 1, so they should all be about the same. I think I had some pictures where the strips kind of look like this. And that's, I mean, that's not acceptable because we're supposed to be having them all be the same length with different levels of kind of even divisions so we can compare the lengths of them and see how much is left over. Is this one all right? Can I erase those 3? Or does anybody need extra time? I'm going to clear it. Density property says that between any 2 rational numbers, there exists at least one other rational number. That leads to an infinite number of rational numbers in between, but the property actually just says there's at least one. And that's number, not mumber. So here where I have my 3/5 and my 2/3, I'm going to try to express them with a common denominator. First, let's try 15. I'm sorry, yeah, let's try 15. When I multiply by this by 3/3, that gives me 9/15. When I multiply this by 5/5, that gives me 10/15. And so it's not real easy to put something in between them. So let's get another denominator. I'm going to multiply this by 2/2. So that's 18/30. And I'm going to multiply this one by 2/2, which gives me 20/30. And between 18/30 and 20/30, between them, could I put 19/30? Density means if they're dense, there's always something in between them. We can fill in all the spaces with more and more fractions. That one all right? Can I erase it or no? I'm not hearing any questions, so I'm clearing. Next one was fraction arithmetic by hand. If I have 3/8 times -4/27, and then divide that by 1/9, well, parentheses first, in order to multiply that, I can divide by 4 along one diagonal and by 3 along the other diagonal. And so that gives me 1/18. And then to divide, we're going to multiply by the reciprocal. So that's 9/18. Whoops, and I lost my sign. That's -1/18. So that's -9/18 or -1/2. Next one, to subtract with a mixed number, I'm first going to change that into an improper fraction. 3 times 2 is 6 plus 1 is 7. Then, in order to subtract, I need a common denominator. So that's 35/4 minus multiplying by 2, 14/4. Then I have to divide that by 7/4. Well, 35 minus 14 is 21. I'm going to keep my common denominator. And again, to divide, I'm going to multiply by the reciprocal. I can cancel out the 4's. So I have 21 divided by 7, which is 3. Next question, a lot of people expanded that to 200 plus 70 plus 3 plus 4/10 plus 2/100 plus 5/1000. But next exponential notation, that would be 2 times 10 to the second plus 7 times 10 to the first plus 3 times 10 to the 0 plus 4 times 10 to the -1 plus 2 times 10 to the -2 plus 5 times 10 to the -3. How are those two? That clearing. An acre is 1/640th of a square mile. How many acres are in a rectangular plot that's 1/8 of a mile by 1/4 of a mile? Well, if I take 1/8 times 1/4, that's 1/32. And then we want to know how many acres are in there. So we're going to divide it by that acre, which is 1/640. I'm sorry, that's not 1/4, that's 1/2. I apologize. That should be 1/16. I apologize. And that should be 1/16. And so that's 1/16 times 640 over 1. And 640 divided by 16 is 40 acres. And so if 1/8 by a half is 40 acres for 80 acres, wouldn't it be twice that, or 1/2 times 1/4 of a mile? Next, we're going to set up a proportion. We're going to compare our gallons to our miles. And so that would be 7.5 is to 125 as X is to 300. And so we'll cross multiply and take 125 times X is equal to, well, if I take 7.5 times 300, I get 2250, and then I will divide. And so I get 18 gallons. Next one, 24 gallons is 2/3 of the tank. So if I take that 24 and divide it by 2/3, that would be 24 times 3/2 would be 36 gallons in the tank. And so she needs, let's see, 36 minus 24, 12 more gallons to fill it. And I think we're almost done. Is everybody done with those three? Can I clear them? Then ratio of boys to girls is 5:3. And so the ratio of girls to boys is 3:5. And so girls to the total would be 3:8. So girls are 3/8 of the class. And we could also say then that the boys are 5/8 of the class. And so when we take 5/8 of 24, we get 15. %, as a decimal, move it 2 places, 0.20. And so as a fraction, that would be 20 over 100, which we could reduce to 1/5. 0.5 repeating is 0.55555, and so it would be 55.5555. Eventually you'd put a 6 there, or you could say 55.5 repeating percent. But that was the challenging one here, because in order to change a repeating decimal into a fraction, we said we're going to let x equal the repeating decimal, 0.5555. Because it has a period of 1, we'll multiply it by 10, so 10x would be 5.5555 repeating. Then you remember we subtracted down and got that 9x is 5. So x is the fraction 5/9. 3/20, we could work with it a couple of different ways. One way, we could first change it to a percent. 3 over 20 equals our percent over 100, which would give me 15%. And so as a decimal, it's 0.15. We could also just take that 3 and divide it by 20, which would give us the 0.15, which we could then change into a percent. Those two all right. Then, can I clear them or do you need more time with them? Can you guys hear me okay?
Yes.
Okay, can I clear them?
Yes.
Okay. I don't remember anybody having a hard time with the computation by hand. Are you guys all right with number 16, or do you want to do them out together?
I'm good as long as everyone else is.
Okay. If there isn't a concern, 17, for their proportion, we're going to cross multiply. So we'll take 0.2 times 0.6 is equal to 0.5 times p. So that gives me 0.12 is equal to 0.5 times p. And when I divide by 0.12 by 0.5, remember we're going to move it over once. And that gives me 0.24. I was surprised with this next one. Some people try to set up a proportion, and in looking at it in a proportion, you got the answers reversed. With these, we looked at the unit price, which was the cost over the ounces. So here we'd have 1.95 divided by 15 ounces, $1.95 divided by 15. So that's 13 cents per ounce. And the other one would be $1.20 divided by 10 ounces, which would give me 12 cents per ounce. And so 12 cents per ounce is the better buy. And the last one, we've got that $500 machine. It's on sale for 35% off. So we're going to multiply it by 0.35. And so when I take 0.35 and multiply it by 500, I get that it's on sale for $175 off. And so when I take 500 minus the 175, the sale price is going to be $325. And that's that. All of the questions on the final come from those 4 tests. Probably about a third of the questions will be on the final. Did this help? Do you folks feel any better about these?
Yes.
Yes. All right. Let me. Oh. Stop sharing. Does anybody want to go over anything else tonight? If you can do those, you should be in great shape tomorrow. Does anybody want to revisit any of those questions, or are we okay? Before we do anything else, I think I'm seeing a couple of names that I did not get on attendance. Ava, I didn't see you here before. And
Hi, I'm here.
yeah, I got you. Anybody else that I didn't gather on attendance?
Did you get me?
Yeah, I got you, Rachel. And thank you for helping me send advice to Anna, although I don't think Anna ever showed up. Did she? Did anybody see Anna in class? Okay, hey, this is it, you guys. Thank you for spending your Monday nights with me for the past 15 weeks. I hope you learned something. I hope you got something out of it. The assumption with this class is that you're all in college, so you all already know how to do elementary school math. Our goal is to try to give you a little bit of an understanding as to why it's done that way, so that when it's your turn to teach kids, you can give them a reasonable explanation as to why it's done that way, instead of them learning, you have to do it this way because I said so. And the reasoning is because if you have to do it this way because the teacher said so, that means I just got to memorize it, and it's just a mystery why it happens that way, and it just makes math so much more confusing, as opposed to if there's a little bit of a logical reasoning behind it, you understand it, and you don't memorize it, and it makes you less scared of math and maybe a little bit better at it. Hopefully another thing you got out of class is, I don't know, when you're that teacher in the front of the classroom, if that's still your goal, you never present something that this is going to be hard. Because if you present something as, this is going to be hard. Did you ever, like when you were a student in class, have somebody say, okay, oh my God, this is going to be the hardest thing you ever did, and you're not going to like it, and it's going to be difficult, and we'll be lucky if you get it. Is that going to give you the right mindset? No. So it's never hard. It's never difficult. It's never tough. Just some topics might take us a little bit longer, but we can do this, and we'll understand it, and we'll, no matter what, try to make it fun. So, end of story. Any questions on any of this? Okay. 2, if any of you are taking Math 109 next semester, or in the summer or the following fall, if any of you have any intention of taking Math 109, you must keep your book and your activity manual. They were super expensive because they count for 2 semesters. You don't want to sell those back to anybody and have to pay for a new one again. Keep your book. So, all right. Otherwise, is everybody got at least 2 hours, if not more, sometime between 8 o'clock tomorrow morning and 8 o'clock tomorrow night where you can take this final? If you don't, stick around at the end of class and I can make other arrangements with you if I know in advance. So otherwise, any questions on anything? Do you guys feel like you learned something this semester? Okay, all right. I know you can do this. Before an exam, I never, ever, never, ever say good luck, because you don't pass exams with luck. You pass exams with hard work and mad, crazy skills. And you guys all have mad, crazy skills, and you've shown me you can do hard work. So put your best foot forward and you'll all do well, okay? Otherwise, have a great night, and maybe I'll see some of you again next semester.
Bye, thank you.
Bye-bye, thank you. Thank you for being such diligent math scholars. I appreciate your attendance, so. Bye-bye.
Bye.
Bye-bye. Egypt, do you have time tomorrow to take the test? When I saw the expression on your face, when I saw that, I thought, I need to talk to this young lady.
My dilemma is I work 10 to 6:30 tomorrow,
Okay.
and I was thinking about taking the exam after work, but I don't know if I'll have enough time to do it. But I was gonna wake up early to take it from 8 to 10, but I have to be at work at 10.
Okay, so would it be better for you if I gave you time so that it's not due until later in the evening tomorrow? Or would it be better for you if I gave you time on Wednesday? What works better?
I can do it as soon as I get out of work or earlier.
Well, right now, let me pull up the test here. And so what I'm going to do for you is find it and make weird sound effects while I'm finding it, because it's past my bedtime. I'm going to, in test options, I'm going to make add a user to the exceptions. And the user that I'm going to add is Egypt. And we are going to, for your exception, say that you can have tomorrow until 11:59 p.m. You'll get it done before midnight?
Yeah, it'll be way done before midnight.
Okay. All right. And it's, 2 hours. If you take more than 2 hours, it'll stamp it as late, but it won't kick you out. Hey, Egypt, I know you've been on this train for a long time. You can do this. All right. Let's make this your last attempt at Math 108. Okay, hon? I am rooting for you so hard. So do your best, okay, honey?
Thank you.
All right. Okay. Is anything else I can do for you?
No.
Okay. Did today help going over those back tests?
Yes.
Okay. All those little fine points, you got to get them right on the final, okay, honey? All right. Then Excel, do well tomorrow, okay? And if you need, if something goes on in your life and you can't get to it tomorrow night, shoot me an email and we can open it for you for Wednesday, all right? Because you've talked to me in advance, I can make adjustments. Okay, honey?
Thank you.
All right, have a great night. Okay, bye-bye.